1. What is Apache Spark? Apache Spark is a powerful open-source data processing framework that offers high speed, ease of use, and flexibility. It was developed using Scala, Python, Java, and supports various data processing tasks. It excels in in-memory computing, making it much faster than traditional processing frameworks. It can operate standalone, integrate with Hadoop, or be used in cloud environments. Spark is capable of accessing a wide range of data sources, including HDFS, HBASE, and Cassandra. 2. Explain the key features of Spark. Apache Spark's key features include seamless integration with Hadoop, an interactive language shell Scala, resilient distributed datasets RDDs that enable distributed data caching, support for multiple analytics tools, interactive, real-time, and graph processing, real-time stream processing capabilities, high processing speed due to reduced disk I/O operations, code, reusability across various data processing tasks, and cost efficiency when compared to Hadoop. 3. What is MapReduce? MapReduce is a programming model and framework designed for processing massive datasets. It divides processing into two stages: map, which handles data splitting and mapping, and reduce, which manages data shuffling and reduction. 4. Compare MapReduce with Spark. When comparing MapReduce with Apache Spark, Spark stands out as it offers significantly faster processing, supports in-memory data caching, excels in iterative jobs such as machine learning algorithms, doesn't rely on Hadoop, and provides better support for machine learning applications. 5. Define RDD. RDD stands for Resilient Distributed Dataset. It's a fundamental data structure in Spark that represents a fault-tolerant collection of operational elements that can run in parallel. RDDs are partitioned, immutable, and can be categorized as parallelized collections or those derived from Hadoop datasets. 6. What does a Spark engine do? A Spark engine is responsible for scheduling, distributing, and monitoring data processing tasks across a cluster. It's a crucial component used for various purposes, including SQL batch processing, extract, transform, load ETL jobs, streaming data processing, and machine learning. 7. Define partitions. In Spark, partitions are logical divisions of data used to parallelize processing. Every element in Spark, including RDDs, is divided into partitions to enable efficient parallel execution. 8. What operations does an RDD support? RDDs support two primary types of operations: transformations. These produce new RDDs from existing ones when a transformation is applied. Transformations are lazy and only execute when an action is invoked. Actions. Actions trigger the execution of RDD computations and return non-RDD results. They are used when you want to collect or retrieve data. 9. What do you understand about transformations in Spark? Transformations in Spark are functions applied to RDDs, resulting in the creation of new RDDs. These functions, such as map and filter, operate on the data, but do not execute until an action is called, allowing for optimization and lazy evaluation. 10. Define actions in Spark. Actions in Spark are operations that perform computations on RDDs and return non-RDD values. They are used when you want to trigger the execution of transformations and collect results. Examples include reduce and take. 11. Define the functions of Spark Core. Spark Core serves as the foundational engine of Spark, handling critical tasks such as memory management, basic I/O operations, job monitoring, fault tolerance, JOB scheduling, interaction with storage systems, distributed task dispatching, and more. It forms the basis for all other Spark projects. 12. What is RDD lineage? RDD lineage is a mechanism in Spark that allows the reconstruction of lost data partitions by remembering how to build them from other datasets. It ensures fault tolerance by tracking the transformations applied to RDDs. 13. What is Spark Driver? Spark Driver is a program running on the master node that defines transformations and actions on RDDs. It creates the Spark context and communicates with the cluster manager. The driver is responsible for coordinating the execution of Spark jobs. 14. What is Hive on Spark? Hive on Spark is a configuration that enables Hive, a data warehousing tool, to use Spark for query execution. It allows SQL queries to be executed on Spark data, promoting compatibility between the two technologies. 15. Name the commonly used Spark ecosystems. Commonly used Spark ecosystems include Spark SQL, formerly known as Shark, for structured data processing, Spark Streaming for real-time data processing, Graphs for graph processing, Malib for machine learning, and Sparker for integrating or programming into Spark. 16. Define Spark Streaming. Spark Streaming is an extension of Spark that facilitates real-time stream processing of data from sources like Kafka, Flume, and Kinesis. It processes data in small time intervals, making it suitable for applications like live dashboards and real-time data analysis. 17. What is Graphs? Graphs is a component of Spark used for graph processing. It provides abstractions and operations to build and analyze graph structures, making it useful for applications like social network analysis and recommendation systems. 18. What does MLLIB do? MLLIB is a scalable machine learning library provided by Spark. It offers a wide range of machine learning algorithms and simplifies the development of machine learning applications. Malib supports tasks such as clustering, regression, dimension reduction, and more. 19. What is Spark SQL? Spark SQL, also known as Shark, is a module in Spark designed for structured data processing. It enables the execution of SQL queries on data stored in Spark. Spark SQL introduces a new data structure called Schemerd, which represents structured data with defined schemas. 20. What is a Parquet file? Parquet is a columnar file format supported by Spark and many other data processing systems. Spark SQL can efficiently read and write Parquet files. It is considered an excellent format for big data analytics due to its storage efficiency and schema support. 21. What file systems does Apache Spark support? Apache Spark is compatible with several file systems, including Hadoop Distributed File System HDFS, Local File Systems, Amazon S3, HBASE, Cassandra, and more. This flexibility allows Spark to access data from various sources. 22. What is Directed Acyclic Graph in Spark? A directed acyclic graph DAG in Spark represents the sequence of transformations and operations applied to RDDs. Vertices in the DAG correspond to RDDs, while edges represent the operations. The DAG is used for optimizing and executing Spark jobs. 23. What are deploy modes in Apache Spark? Apache Spark supports two deploy modes, client mode and cluster mode. In client mode, the driver runs on the machine from which the job is submitted, while in cluster mode, the driver runs on Spark clusters independently. 24. Roles of receivers in Apache Spark Streaming. Receivers in Apache Spark Streaming are responsible for consuming data from various data sources, such as Kafka or Flume, and then transferring it to the Spark cluster. There are two types of receivers: reliable receivers that acknowledge data receipt, and unreliable receivers that do not. 25. What is Yarn? YARN, yet another resource negotiator, is a resource management platform that plays a key role in Spark by providing central resource management and scalability across a cluster. Running Spark on Yarn requires a compatible Spark distribution built with Yarn support. 26. List the functions of Spark SQL. Spark SQL can load data from various structured sources, execute SQL queries, integrate SQL with external tools using standard connectors JDBC, ODBC, and provide rich integration between SQL and other programming languages, allowing for operations like joining RDDs and SQL tables and exposing custom functions. 27. What are the benefits of Spark over MapReduce? Apache Spark offers several advantages over MapReduce, including faster in-memory processing, built-in libraries for various tasks, batch processing, streaming, machine learning, support for caching and in-memory data storage, and the ability to perform iterative computations. These features make Spark more versatile and efficient for diverse data processing workloads. 28. Is there any benefit of learning MapReduce? Learning MapReduce is valuable as it forms the foundation for many big data tools, including Apache Spark. Understanding MapReduce concepts helps optimize data processing tasks in various environments. Many tools, such as Pig and Hive, convert their queries into MapReduce phases to enhance performance. 29. What is a Spark executor? A Spark executor is a process in Spark that runs computations and stores data on worker nodes. Executors execute tasks assigned by the Spark context, making them responsible for the actual computation within a Spark application. 30. Name the types of cluster managers in Spark. Spark supports three major types of cluster managers, standalone for basic cluster setups. Apache Meso is a commonly used general-purpose cluster manager, and YARN, the Hadoop Resource Manager responsible for resource allocation in Spark. 31. What do you understand by a worker node? A worker node refers to any node in a cluster capable of executing application code and participating in distributed data processing. It plays a crucial role in performing computations within the cluster. 32. What is PageRank? PageRank is an algorithm used in graphs, a component of Spark, to measure the importance of vertices in a graph. It assesses the influence of one vertex over another in the context of a graph, often applied in scenarios like social network ranking. 33. Do you need to install Spark on all the nodes of the Yarn cluster while running Spark on Yarn? No. It is not necessary to install Spark on all nodes of a Yarn cluster when running Spark on Yarn. Spark runs on top of Yarn without requiring individual installations on each node, simplifying cluster management. 34. Illustrate some demerits of using Spark. While Spark offers numerous advantages, it can consume more storage space compared to Hadoop and MapReduce due to its in-memory processing. Developers must carefully distribute workloads over multiple clusters to avoid overloading a single node and manage the associated storage requirements effectively. 35. How to create an RDD. Spark provides two methods for creating RDDs by parallelizing a collection in the driver program using the parallelize method, or by loading an external dataset from storage systems like HDFS or shared file systems. 36. What are Spark data frames? Spark data frames are structured datasets where data is organized into columns, similar to tables in relational databases. They are optimized for large-scale data processing and analysis tasks. 37. What are Spark datasets? Spark datasets are data structures introduced in Spark 1.6 that combine the benefits of RDD's ability to manipulate data with Lambda functions with the Spark SQL-optimized execution engine. They provide a strongly typed interface for distributed data processing. 38. Which languages can Spark be integrated with? Spark can be integrated with various programming languages, including Python using the Spark Python API, R using the R on Spark API, Java using the Spark Java API, and Scala using the Spark Scala API, allowing developers to work with their preferred languages. 39. What do you mean by in-memory processing? In-memory processing refers to the practice of accessing and manipulating data directly from physical memory RAM rather than reading it from slower disk storage. This approach significantly reduces data access latency and accelerates data processing tasks. 40. What is lazy evaluation? Lazy evaluation is a strategy used in Spark where computations, especially transformations on RDDs, are not executed immediately when defined. Instead, they are evaluated only when an action is invoked. This optimization minimizes unnecessary computation and improves performance, especially in the context of big data analytics.